welcome to all of you to this program, to this conference, which is on leverage cloud edge to ensure success in a hyper-connected world. Uh, this program and this conference has been organized by ETCIO in association with Tata Communications. My name is Muqbil Ahmed. I'm the executive editor at ETCIO and the moderator for this session. Before we start, I've already told you about the topic for discussion today. And but before we start, let me lay down some kind of a brief context for the discussion at hand. We would all agree that digital transformation has really taken off. I mean, an ever increasing number of enterprises are taking that route. And there has been a concomitant explosion in the number of devices, in connectivity. All this has yielded to an astronomical quantum of data which is being gathered, which is being generated, and all of that. Now, we have also come across such sayings as data is the new oil and all of that. Now, we do believe that the current IT infrastructure that is there is probably not sufficient to help enterprises really make the most of this oil, so-called oil. Some people call it gold. You can call it whatever you want, but the idea is that it is an invaluable asset. In pursuit of leveraging this invaluable asset, we do feel that we need a distributed IT infrastructure, particularly cloud. And edge computing forms a very integral part of that. That is exactly the discussion that we are going to have in the panel discussion, which ensues right away. We would be talking about things like the challenges that enterprises face as they try and leverage this data. Also, what could be the best practices for enterprises as they try to make the most of this asset. Understanding the data landscape, how do you ensure reliability and performance of edge computing, how do you optimize costs, improve operational efficiency, ensure compliance, and all of that. So without much ado, let's deep dive into the conversation at hand, which is the panel discussion. And to discuss all this, we have a brilliant lineup of extremely insightful speakers who are all there in front of me. It's my pleasure to introduce the speakers for this evening and this panel discussion. I would first like to call upon Balpreet Singh, Head IT, Alembic Pharmaceuticals. Could we all welcome him with a round of applause? Satya Narayan, Head of IT, Bajaj Auto. Please, can we have some energy in the room? Come on. We are not old people. We are very, very young, energetic people. All right. Rishi Jagmohan, Head Digital Transformation, Work Hard. And he has also written a wonderful book, an Amazon bestseller called Are You a Digital Dinosaur? So this is a question. Are you? Or are you not? All right. And last but not the least, it's my pleasure to introduce Neil, Senior Vice President, Cloud and Edge Computing, Tata Communications. Please welcome him with a round of applause. All right. I will be moderating and hosting this session. Thank you very much, and we look forward to a great discussion. All right. Right. Starting the discussion first with Rishi. So Rishi, as I spoke during my context setting as well, there has been this huge explosion in the number of devices which are interconnected, and digital transformation journey and the ways and means to gather, collect, analyze all of this data. So I really want to understand from you, what are the challenges, the most pertinent challenges that you feel that enterprises today face in their pursuit to make the most of this extremely invaluable asset?
Thanks, Muqbil, and thank you, Tata Communication and ET, for having us here. Before I give you a straight answer, let me tell you a small incident which happened yesterday only. One of my friend, his daughter, he came to Mumbai to leave his daughter, who's going to work in one of the consulting companies. So as usual, particularly people coming from Punjab or Delhi, they're very, very, caring about the children. So they put her in the hostel somewhere, very, very connected hostel, I'll call it. And it's good as well as bad because parents can track their children over there, where they are going and when they are coming back. But the daughter is not very happy about it. So
Nobody would be happy with such surveillance.
so those kind of challenges are there of having connected devices also.
True, true.
Well, coming to your question straight away, there can be multiple challenges with this explosion of connected devices. To name a few, let me start with the names only: data management and storage, then of course data integration, data quality, privacy and security. At the same time, the cost factors are some of those aspects, and most importantly, my favorite is skilled workforce. Okay, these are some of the challenges which organizations are facing. Coming to specifically data management and storage, especially when in the manufacturing sector, when we are introducing IoT sensors. So, as we were discussing beforehand only, that IoT is expanded version now. You can get data from the videos or drones also. So all those data is getting accumulated. How to collect the data and how the storage is coming over there, that is one biggest challenge. Second is the integration of this data. I mean, you are getting data from diverse sources. Typically, take example of healthcare like ours. We are getting, immense amount of data from patients, from doctors, from stockists, from semi-wholesalers, connected devices also. These days, connected devices is a they say fad of the month kind of thing. So we get a lot of data. We don't know whether it is right or wrong. I mean, every day you read that Apple Watch has saved a life. I don't know whether it's true or not, but these are also some of the factors which are talking about the data integration, and of course the quality of data. What kind of quality of data are you integrating and storing it? That is something which is very, very important, particularly when particularly from the financial perspective, a lot of frauds are happening kind of thing. So those are aspects. And most importantly is the cost factor I'll talk about. I'll not talk about others, but cost factor is very, very important. And because a lot of organizations are demanding analytics and the ROI of those invested devices, connected devices. So, I mean, those meaningful dashboards and real-time dashboards should be giving some kind of idea to the decision makers whether the cost is justified or not. I hope I answered your question to some extent.
Yeah, you have answered it very, very comprehensively. And great points coming from you, Rishi, about data integration as well as the quality of data. Two very critical points as enterprises try to leverage the full power and unleash the power of data, so as to say. Balpreet, your views on it.
So apart from what Rishi has told, so I would put a couple of more points. One would be around data security. Now that so much of data that we are generating and we are also wanting to open it up to our employees or our stakeholders. So how do we ensure security part of it? So that's one point. And then maybe a little more on the analytics, that while so much of data would come in, the challenge for us on the IT side would be, now somebody in business would have heard something about any new fad for that matter, and it will come to us that why can't we do it? So it will boil down to that, can we stay ahead of the curve in terms of making some meaning out of that data? And a lot of times this data would still be in silo. While we are generating, it could be one plant data at one plant, it could be a supply chain data some other place. How do we integrate taking care of the security of data and then trying to get some meaningful insights out of it? So those would be my add-ons.
Right, very interesting points where you spoke about security. And I know this is a very august audience, just to give an idea of the, the extent of data explosion, I was reading some report and it said that in the next couple of years, there would be 70 odd zettabytes of data in the world. And one zettabyte is equal to, I think, a trillion GBs, something like that. Huge astronomical numbers coming in as far as, and I think we are all aware of this, the amount of data that we use day in and day out. And if you were to compare it to something like a decade back, when we started with 250 MB or something, I mean, it's a real explosion. Uh, Going back to Rishi, so Rishi, you have spoken about the challenges that enterprises face in their quest to make the most of this extremely critical asset. What role do you think can edge computing play in all of this?
Made as opening batsman. These days, opening batsmen are not working
You are
very
the
well for
Sachin Tendulkar.
India.
Or Navjot Singh Sidhu.
By the way, Virat
Both
and
rolled in one.
Anyway, we'll try our best because we're going to West Indies now. So let's give the best of the thing. I mean, edge computing, of course, plays a big role in leveraging data, frankly speaking. I think I'll cover some of the aspects which I covered earlier also from the security point of view, from the scalability point of view. These are two aspects which are very crucial, but at the same time, there is another very important aspect of having edge computing is on the reducing latency part. This is something which is crucial because processing data closer to the sources minimizes the latency and of course enabling faster decision making and of course real-time analytics. So I think this is one aspect. At the same time, I think I covered about the security, enhancing security. Having localized data processing can improve the security point of view. And one more aspect which I can mention about is the bandwidth efficiency. So this is another aspect which can consider about it. Anything else you would like me to cover on that?
Great. Balpreet, you want to add?
So I think in terms of latency, the other would be that if I have to respond to something very quickly, so therein having the processing closer to the device would help. So if I am doing, let's say, video surveillance, or if it is something about a safety of a person working somewhere on a shop floor where there are very few people, so that sort of a gap of time, probably even if it is few seconds, could be futile. So I'll probably stress on that these are how, on safety part of it, even saving few seconds could be of lot of benefit.
Very interesting. This is, you have kind of resonated with what Rishi already said about the latency aspect. Satya, what is your view, when data is being captured at the edge and processed there, your views on it? I mean, what are the various parameters that it can have a great impact on? Can you take the microphone? Hello.
So I just wanted to do a little context setting, if that is okay.
Yes,
Right.
please go on.
So I head the IT for Bajaj Auto, and I come from the place where our products, which are basically vehicles, be it two-wheelers, three-wheelers, are sold in 70 different countries, and that's why we are called as the proud Indian. Which means every country we sell, there is something unique about the data, even though it is common across vehicles. Vehicle goes at a certain kilometers, at a certain mileage, and so on. But when it goes to Nepal, vis-a-vis, it goes to Africa, or Europe, or any other place, it has different data sovereignty issues in the sense that you have to protect certain data, which is HIPAA compliant or whatever it is. That is one part of the data. And then I work at a level of operations, which means I handle about 200 odd softwares with 7 different protocols and so on. So I come from that operational, what we call it as OT, related to the equipments and other stuff. And then there is an IT portion, which is the data portion. So IT, OT mixture multiplied by the operations versus the strategic. So that is where, from where I come in. And the products that I do or we do basically contains right from sensors to IoT devices and so on, and the perimeter which is moving. which means a vehicle. You're not catching a data from a tablet or a machine which is in your desktop, but it's something that is moving, which means the security and the perimeter also keeps moving. So this is a broad level context. But there are some finer learnings as we go through, right? So I'm going to take some extra time to kind of tell you that. So if you see data everywhere, not a drop to drink. That's how it is. Because if you line up all the data in the world as a book, you can go to moon and come back, right? That's the simplest of it. And if you take all the 4 social media, they just generate about 4 petabytes of data of just Facebook alone, and then Amazon too. So basically they create so much of data. 85% of that data are just copies, right? While so much is being generated by a section, 40% of the remaining world doesn't have a data. They have data, but they don't have some means to kind of capture. Now, social media, people, the divide. Now, a new introduction comes, which is machines or wearables or smartwatches kind of stuff. So they add to the pool of data generation. So roughly, if you take, as per estimates, 73 times the data will be generated by machine as against the men today who are generating, right? And then why so much is basically the number of devices that we use on an average has increased from 1 to 3, right? And then the acceleration of fast internet, right, from 3G, 4G, and 5G has contributed to lots of processing power, right, in terms of the speed of what it can do. So we are generating substantially large volume of data. We are also creating junks. And there is machine to men or people generation of data. Okay. And then now, where will it be available? If you take a rough estimate of it, 50% of all the data will be in the cloud. Okay. 1/3 will be in the consumer device, another third in the traditional enterprise data centers, and the final in the cloud. Now we have dimensions of IoT coming in and adding more data into it, right? So now, who owns it today? It's Google, Amazon, Microsoft, Facebook, almost consuming the entire data portion of it. Now, in such a data pool of people or people-generated data, how machines are going to interact? Whatever be the technology, it is not sustainable to locate so much servers, so much power, and so on. That's where the need for edge comes in, be it on top of edge compute or edge servers and so on, right? Now, earlier, the content was all about a search, roughly about, if you take Google processes about a lakh of search per second. So the compute is in terms of only the content, not actually processing something and giving an output which can act on something, right? Now, the telecom operators are coming. Which way this thing is going to go as to the edge, whether a telecom operator is going to take over or the big hyperscalers are going to take over, is a choice of the day as we come through, but there is a lot to be done. That's the gamut, right? If you talk about speeds of processing, right, what is the accelerator in it? 3G, if you take a ET movie, right, about 2 hours of movie, you will take 12 hours to read it on a 3G, okay, and 10 minutes on a 4G. And in 5G, you can actually download it in 3 seconds, right? That's the rapidity of it, right? And then once these 5G plus the cloud establishment comes in, now we still have bandwidth issues and latency issues, which means the data can process in so much of big amounts. But when a sensor wants to react on something, let's say 3 seconds before somebody could apply a brake and avoid an accident, you have to be 10 times much faster in terms of going and coming back with the data. So all the way going to the cloud and coming back is not a common sense, right? So now, the bandwidth speeds, if you could see, average speeds is about right from 200 Mbps and so on for 5G. And then according to it, it will be 17 billion devices that will be connected. So this is the landscape, right? So from the landscape, where we go is basically there are different regions that were needing different types of processing of these data, which means these are not data that is gone to a server, come back. They are processed, which means 49% of the data will be stored in public cloud, whereas 30% of the generated data will be consumed in real time by the end devices. So there is a case for processing it locally, right? So finally, if you talk about a specific example like IoT, right? IoT, 74% of the IoT devices are short range, which means you need solutions which are local in nature. All the way going through a round trip to cloud and then coming back isn't a value proposition in it. While doing so, these technologies come and go. If you see 2018, 2022, 2024, in 2018, there was so much hype about edge computing. Today, in Gartner survey of 2024, it doesn't appear at all. So there is also a hype cycle, there is a production cycle, and then there is a fulfillment cycle in terms of where it gets stabilizes in terms of productivity. So when we say that IoT or edge, they have a classic case of about 30 to 35% adoption rate, which means you have the right use case, 30% of it can get converted into value as of today, right? So that's the overall nutshell I would like to talk in terms of the data on the cloud, the IoT, what is feeding into the IoT data, and what comes out of it, and what are all the two factors in terms of the speed, in terms of bandwidth speeds, and as well as in terms of the latency that are required. So further down, I'll be talking about two latency requirement specific use case that I have gone through, one in terms of AR, VR, the other one in terms of the connected vehicles, which we'll talk about when that round comes in. Yep.
Great. You can elaborate, Satya, no problem. You can elaborate on those use cases as well as, the content that you have.
Okay. So basically, if you take a AR, VR kind of an environment, it's basically a head-mounted device which has some intelligence. Not that it has to be connected to internet all the time, because you have a software which can host a CAD model, and that would be transmitted to your head-mounted device where you can see in real time. Either it is in a virtual context where there is purely digital model, or augmented model where you have something to augment on the real sense, and then you have mixed reality where you can actually take a bike, keep it, and then you can project onto a digital model and see what it is. So it helps a lot in terms of not just visualization, but in terms of collaboration, because we have multiple studios across the world. So when people want to engage in collaboration, right, these are in terms of milliseconds. So you can't all the way go on a round trip to the servers in US, which is on cloud, plus the data governance, which means you have IPs which cannot go and transmit over the internet. So it's a classic case of data have to be local, and the use case mandates that you have to have it protected here, and then collaboration still has to happen. So for example, the fastest muscle in our body is eye, right? About 10 milliseconds or less. And then whenever collaboration happens, a CAD model of like say 4 GB has to be transmitted. It is virtually not going to be possible, except for few like PDC's Onshape and other softwares. The CAD is not well tested in a cloud model. Whereas collaboration of the data, like pixels going forward and backward, has to be in that set of milliseconds. So there is possibilities of local processing and latency, because if you miss that 2 blink of an eye, which means if there's anything that hasn't changed or gradually changing, you don't get the experience of collaboration, because that is where the key point where your designs are ideated. It is not in isolation between you and a CAD software. So these are critical time-sensitive cases where it is not something like you fall into an accident, but really the experience of doing a particular work at the productivity level is what I'm talking about as a edge. So that is one scenario. The second scenario is a classic, the time to break, like 3 seconds to break so that you don't hit somebody. All these machines or say vehicles, if you take in general, be it a 3-wheeler, 4-wheeler, has different ECUs, MCUs, sensors, and so on and so forth, right? So if you take approximately all these starts generating data. Coming back to the other point, let's say I'm just giving not perfect numbers, but market average is what. So a per vehicle, a day vehicle of information would be around something like, total about 20 TB of data. Okay. And what you need for action is only 1 TB of data. It might be a canned data, it may be connected data, or whatever it is. So that you don't need to boil the ocean, because for action you need only 1 TB. Okay. And even in that 1 TB, you might action be about certain MBs only is needed. So if you trip from TBs of 10 TBs to 1 TB to 1 MB or so, is all the flow down. And it doesn't make common sense to go all the way to the cloud. But if you want to really see the performance of the vehicle, some insights, yes, they have to go back to the cloud. But these are the two things for action on any connected devices or things. The latency is highly critical, not in terms of the action, but also in terms of the experience. So that's where anybody who is embarking on a project of edge computing or use cases like this have to not look at the promises of the technology, but on what use case can it really solve, and are you in that 30 to 35% adoption cycle success rate is what you need to ask yourself. Thank you.
Very pertinent points and well taken. So I would now want to pull in Neil into the discussion. So Neil, I mean, any discussion today in technology cannot escape that subject called AI. Can it? AI, ML is in the air. We are breathing that air. So how do you put both the things together? I mean, edge computing in the day when AI has taken off in a really, really big way. How do you see all of that coming together and providing a wonderful experience to enterprises, helping them in making decisions, and all of that?
Yeah, sure. I'll answer that question. But before that, I just wanted to make, and thanks. I think my job has become easy in terms of my presentation, because my initial few slides were going to cover all the, the need for edge and the challenges, etc. So I'm going to just summarize the conversation so far, right? And then I'll come to the AI part. So why do we need edge computing? Because there are like zillions of devices sitting out there. So much of data getting generated. I think the next phase of digital transformation is to see how you can use that data which is getting generated machine to machine, machine to human, human to human, wearables, drones, robotic devices, etc. So how do you, meaningfully extract information, act in real time, draw insights, and then and maybe create operational efficiencies, reduce costs, and also discover and uncover new revenue streams. I think that's the holy grail, right? You want to be able to monetize this data, right? So I think that, but from the challenges point of view, I think security was covered, very, very important skill sets. And I'll talk about how CloudLight, which is our platform, provides a managed services, an expertly managed platform. We talked about data residency and data sovereignty, why you don't want to take the data out, because there's a lot of IP in that data, specifically in manufacturing setup and in pharma setup. So you don't want to take the data out. And also now you want to be able to granularly control the data in an IT/OT setup, right? You want to be able to use those levers to see which data, how granular I want to control. And that control can only happen when you have something locally being done, right? Processing being done, or orchestrating the data is being done locally. And last but not the least, from an access point of view, we have IoT and 5G, Wi-Fi 6. 5G obviously means tremendous amount of bandwidth being available, but what do you do with the bandwidth if you're not able to, do something to, meaningfully out of it? Just, having all your devices on a high-speed network will not mean anything unless and until you're able to, get the data and act on real time. Therefore, edge computing. So I think that's very clearly established so far. I think what is important to also bring in, apart from skill set, is, and the security is one very important thing, which I will cover during my presentation, if you have time, is when you're talking about edge, it's all about hundreds of deployments, as opposed to 2 or 3 cloud deployments, or in hybrid setup, one on-prem and couple of multi-cloud environments, and therefore it's easy to manage it. So how do you apart from the surface area being increasing for attack, which is security, so these are the twin problems. One is, how do you ensure that you're creating a secure framework to handle all these hundreds of compute deployments, because at the end of the day you are going to process something, so there are applications which are running there in that constrained environment. And very importantly, from a purely IT point of view, how do you manage and orchestrate so many edge compute deployments through a single pane of glass? So, edge, if you really see, there have been always on-prem deployments of, mail server, there is a server room. It has been existing for such a long time. CDN is a use case which has been around. So why suddenly we're talking about edge computing? And that I want to bring to one point which Satya brought in from a Gartner point of view, where you're talking about the disillusionment now, and then now edge is not appearing. Actually, edge now, according to us, or me maybe, has also got merged into the cloud to edge continuum. So edge is part of the same continuum. And now that the CIOs and the CTOs and the businesses are used to handling cloud in a particular fashion, which is having that agility, scalable, environment, easy to use, self-serve, spin up a virtual machine, within seconds and minutes, and then be able to deploy your workloads on top of it very easily, all the images being available. And that's the same thing happening to the edge. That's the difference between the earlier edge environment and this edge environment. So when I'm talking about a single pane of glass, you have thousands of locations, and through a single pane of glass, an admin can actually deploy Dockerized images, can orchestrate, provision, granularly control data. You can have different application images of the same, POS machine in different retail stores from a single pane of glass. You can do, CI/CD as a service. That means you can, like the way, every time you switch on your TV and Netflix is updating, you can do that on a daily basis, which is unheard of, right? On an edge compute platform through a single pane of glass. So you can do that, you can do role-based access. So multiple things, basically taking cloud to the edge. And that is the next phase of, what we call as the modern edge computing, which is based completely on a containerized environment. Of course, virtual machines will be supported because applications mostly are still virtual machines. Still a lot of plonking of virtual machines are happening, but over a period of time, and I'll come to ML, over a period of time, we're seeing a lot of containerization of the edge. And as that happens, basically having a microservices architecture and using API-based integration with the backend cloud. And cloud is still important because, as you said, most of the heavy lifting will be still happening in the cloud. All the applications will have the backend in the cloud. Metadata will reside in the cloud for posterity and archival purposes. You would do pre-processing at the edge, and you'll be able to do it at a microservices level through this containerization. You'll be able to do it. Now, coming to AI ML, not to belabor that point. Once again, when you're talking about data, when you're talking about processing the data and analyzing the data, we are talking about some learning algorithm, deep learning algorithm. So machine learning has been around for about 15 years, at some point at the edge, but now it's getting, the algorithms are getting so good that you can put it in more and more constrained devices with low memory. You can put it on a Raspberry Pi, you can put it on a device. Video cameras are having video analytics use cases embedded in them. AR, VR glasses will have some algorithm running. So now with AI, so when we talk about AI ML has been existing, right? So when we are talking about AI in this current context, we are actually generally talking about the Gen AI and the LLMs and those aspects. So we've gone a full cycle, right? So we had ML models, AI ML models deployed at the edge. They're getting more and more refined. And now with the ability to, train large language models and bringing the transformer architecture to the AI world, what you're essentially being able to do is actually train these the models in the cloud, and then what we call as quantization of these models and deploying it at the edge. And because of the GPUs being available, more and more GPUs being available at the edge in constrained environments like a Jetson card from NVIDIA or even L40S, we are deploying our AI cloud. We're going to build a large L40S for inferencing. Those L40S can also go at the edge, and you can do real, what do you call, millisecond, inferencing at the edge. And vision models and other analytics, IT, OT analytics, Industry 4.0, all happening at the edge in real time. So what we're essentially seeing is an explosion of new models, basically because of the accelerated compute available in the cloud on very powerful GPUs like H100, quantization of the models and getting deployed at the edge. So that's the next wave. And very important, I think, the component to enabling this, apart from the infra which is available and the ML algorithms, is the data management part of it and the analytics part of it, which was always existing, but now it is even more important because your ability to create pipelines and ability to create what we call as RAG in the Gen AI world, retrieval augmented generation, RAG, is very, very important. So the ability to control these pipelines from a data management point of view is important. So your ability to extract the data from the edge using connectors, ready-made connectors, whether it's to OT systems, to PLCs, to MES systems, and then combining it with enterprise data in real time and using the power of LLM. Now you can see with Apple introducing ChatGPT on your, so the power of LLM is going to be like tremendous. It's just going to be the next wave of, and I believe, I think truly, Satya, once again making that point, I think edge computing once again will become fanciful because of how you'll be able to deploy these models at the edge. Inferencing will be happening, right? Inferencing is going to happen on Apple iPhone. Samsung has introduced, then there are this concept of AI PCs, which have come in. Dell has introduced an AI PC. So I think the world is wonderful.
Wonderful. I think that's a very optimistic note on which you have ended your remark. Continuing with you, Neil, what is the importance of cloud and infra-agnostic multi-access edge platforms?
Okay, so that is actually that's a very important, I think, from a provider like us. I think that's a question for providers like us, who I think are at least we very proud of the fact that one of the design principles for building the edge computing platform for us was that we will make it infra agnostic and cloud agnostic. And the reason was we want to give choice to our customers. We want to make it completely open, in terms of not a closed system. So the ability to deploy any kind of use case on existing stroke new hardware. So we don't want to do a refresh. We don't want to, when we go and say that, okay, I can deploy these use cases on any kind of use case, AR, VR, or we talked about multiple use cases here. Any kind of use case at the edge, we don't want to go and tell our customer saying that, oh, you know what, you've been running this on this kind of servers, this kind of storage. No, this block storage will not do. You need to get, object storage. No, this, vendor will not be supported. Please buy storage from this vendor. Your old servers which still have life, let's say they are 3-year-old, we don't want to suddenly say that, no, this servers will not do, buy new servers. Because there's one very important point. It doesn't meet, unfortunately, we still have to prove the ROI. Fortunately or unfortunately, right? So edge use cases are in a very, very, a tricky slope of going down very quickly. And many of the edge use cases don't come to life and they die a death during the pilot phases not because technology is not proven. They prove the technology, but unfortunately, when you want to commercialize it, you hit a finance wall. right? You want to prove the ROI at scale, and people suddenly say, oh, you know what? Okay, this is cost is saved, but if I have to deploy it, then I'm not going to really make any money, right, over 5 years or over the life of the project. So it hits that kind of wall. So we want to make sure that we are able to generate ROI on these deployments. So one is agnostic. So shove any kind of hardware underneath our platform, because we are a software platform. We work with any kind of hardware. So one is on the hardware side. Very importantly, on the cloud side as well, because all our customers, or many of our customers, are on various maturity phase of their cloud journey. They could be on single cloud, they could be on a multi-cloud journey, or they could be on a hybrid cloud, hybrid network and hybrid deployments on-prem. So we don't want to restrict saying that we will work only with AWS or we work only with GCP. So the other design principle is that no matter what your backend application is, we will have API integration with every cloud provider. So we have API integration with all the 3 major hyperscalers. We have API integration even with Ali Cloud for supporting some of our customers like JLR who are in China. So we want to be able to deploy these use cases whose backend could be in any kind of cloud. For example, over a period of time, I saw one of the bullet items in that slide. 69% of CIOs have already deployed use cases. So it's not as if, when we go to a CIO, he's hearing edge computing for the first time and say, oh, you know what, I've never heard of it, right? They already deployed some use cases. So the use cases have been deployed, but they've realized that over a period of time, they've got one use case from this startup, another use case from another ISV vendor, and these have been deployed in various other devices. One has got the microservices backend in Azure environment, another one on AWS, and we cannot go and say, no, we only work with AWS. Now not only change your hardware, but also, of course, they will not change the application because they've already deployed it, but change your hyperscaler. That's not going to happen. So we want to have a same platform which is extensible and connects to any kind of cloud backend, can abstract any kind of hardware. So we achieve the trifecta of software-defined compute with software-defined networking with software-defined storage, and added on top of it software-defined security. That's what I meant by being agnostic to cloud and the underlying hardware.
Wonderful.
Infra.
I see Satya smiling. You want to add something? No. Your presentation has been very productive. It is being used by other people also.
That's okay. It's all the data. Data is very democratic. So the thing is that as such, any projects, right, like the plateau of productivity, as they call it, to get, it's a big exercise when you consider yourself as a CIO or a CTO or a head of IT being in a company. Because at the end of the day, whatever might be the diamond worth, you are going to buy it at a cost. So it is based on a 1.5 year thought process that you have budgeted. So if you don't have the right insights, because proof of concept is not proving a technology. There are any technology you take in the market, at least 90% we have seen is that it doesn't fail. But is there a use case that you are trying to solve? And are you targeting the right use case? Because most of the money is not spent on proof of concept. It is to prove that this is the right use case to solve. Because many a times when you're going through an edge kind of a use case, you yourself are not clear about, because what you hear in front of you is all promises, right? This company has done, that company has done. Hey, I went to a meeting, I went to a conference, this is what they said. Can we evaluate? But at the end of the day, it is that insight for which you are paying money to prove a concept. And then once it is determined, then you take it forward. Frankly speaking, it's almost like 50% of the proof of concept have only ended up in use cases that are very validated by a sponsor in your organization, and that had a 30% adoption rate. It's not just God gives you a blessings, the receiver has to use it. So that is also a point over there. And with particular to do with edge computing, I think Gartner took a survey again lately, and as Neil said, is that 69% of the CIOs have a use case now. Now to convert it into an action and to be a productionizing that is a question of time. But that's where it is. Select the proper use case, put a money for generating insight to prove that this is the right use case, and then bet your money on that.
Right. So blessings are not enough. Neil, so how can Tata Communications help in all this, providing a robust edge computing platform which helps enterprises leverage the asset that they have?
So I think much of it, I think I've taken, it was a long monologue. So our platform is called Cloud Light, no pun intended, light as in LYTE. And it's actually taking the cloud to the edge. That's our promise. You'll, when you get that single, as in the single pane of glass or the console, you can do you can do whatever you need to do to deploy these use cases. But very importantly, I talked about provisioning, orchestration, I talk about security, etc. But also importantly, and I'll maybe briefly present it, depending on how much time we have. Very importantly, we're also working with, Edge is all about use cases, right? He talked about it. Yeah. So very importantly, we're making a use case marketplace, because our conversations, when we go to CIO, and all of you have said the same thing, when we go to a CIO, we can't go and say that, I have a beautiful edge computing platform which has software defined storage, how does it matter, as in how is it going to solve a problem for me, right? So the whole idea is, okay, if you're going to a manufacturing customer, can we talk about use cases which matter? Are we talking about IT/OT integration? Are we talking about Industry 4.0? Are we talking about predictive maintenance? Are we solving some supply chain challenges? Are we solving a worker safety problem which could be there? Is there a very robust video analytics roadmap which that customer has? Do they have pain points in running those in low latency format, etc.? So we are going to talk about use cases all the time. So we are trying to build we are not a use case company by ourselves. We don't have domain expertise. We are infra and platform provider. We do have managed services to support our platform. So we'll have to obviously work with providers who build these use cases. And what we are trying to do is we are trying to get this library or a marketplace of use cases like hyperscalers have, right? Hyperscalers do have big marketplaces, and go and present a POV, a point of view on what is contextual to them in terms of some of the problems which we believe. And then of course it's, during the course of discussion, we understand what could be possible. So the idea is to actually have the stack which makes business sense. And then we can talk about the bells and whistles and the and what is under the hood. So we start with the use cases and business problems which can be solved, and then come down to the, as I said, to under the hood and unpack what we have. So that's how we start. So in a sense, I think I talked about it. Being agnostic, infra-agnostic, be able to abstract it, be able to provide a silicon diversity, which is also important now. We can, that's becoming increasingly relevant in the AI world as well. Being able to provide x86 architecture, GPU architecture, being able to run on a very constrained environment like a ARM, Raspberry Pi, being able to run on tens and hundreds of servers. If you have an on-prem data center, Cloud Light can run. So we do have scalability. Being able to do horizontal scalability and vertical scalability, so that if new use cases are getting added, the IT teams don't have to worry that, I have to now provision a different kind of control plane, and I'll have to have a different logging mechanism for that. So the same compute platform gets extended. And then very importantly, we are also providing drivers which are natively within Cloud Light. I think that's something which I wanted to present, which is we also provide private 5G for our customers, but irrespective whether it's private 5G from us or somebody else, we have 5G drivers, so we can actually have the RAN components of 5G and 5G core and user plane function out of the same compute platforms. You don't have to have separate boxes to run 5G. You can run your LoRaWAN protocol also out of the same edge computing platform, your Wi-Fi 6, and also your external connectivity for SD-WAN. Let's say you are running SD-WAN, we can put your VNFs, SD-WAN VNFs. So we take care of the access layer as well. So infra layer is done, access layer is done, and then a very strong provisioning orchestration platform and a data management, which I talked about, establishing the ETL pipelines, be able to do dedupe at a local level, be able to create a small lakehouse at a local level, and then run analytics through ML engine or whatever on top of it. Have a very strong AI ops. We've introduced AI ops, and I'll talk about it during my presentation. And then on top of it, use marketplace of use cases along with our ISVs. I think we have the full stack. I believe we have the right to win in this market. Only time will tell.
Wonderful. All the best to you. And
you.
we should definitely leave something for your presentation also. But it's been a lovely, lovely discussion today. Very insightful. And I thank all of you gentlemen for sharing your thoughts and perspectives with us. It has been actually a deep dive, the extent of the depth that we have that we had in the conversation and the insights which have emerged over the past hour. Thank you all for joining us today. I would, as I said, I would now leave to your devices. Your presentation is coming up. All the best. Thank you. Thank you, gentlemen.
Thank you. Thank you very
A round
much,
of
Mukhi.
applause for the panelists, wonderful panelists that we had.
Okay, I think much of it has been covered. Thanks a lot once again to be here and being a very patient listener to what we had to talk during our panel discussion. I think much of it has been covered, and much of it, I think, when Mukbil asked me about what we bring to the table, I think much of it has been covered. But now these are organized into slides, so obviously it will be more structured in the way I presented, and I'm not going to take much of time, given that it's end of the day. I'm not going to cover these. These were, I think Satya talked about most of it. Most of these figures were given by Satya. One very important thing on the last is the ML one. By the way, at least we believe in Tatacomm that all these figures which are given by Gartner and IDC have been already exceeded. This was for 2025. We believe this has been exceeded long back. 75% of enterprise generated content has been generated by 2022, 23. COVID impacted, because this was pre-COVID. This was predicted in 2019. They never realized that something of that sort will come and hit us. And similarly for devices, and similarly, but one thing which is 50% of applications are going to be, ML. That's also we seeing whenever we go, except for AR, VR, and let's say even not even robotics, AR, VR, and some few, all video analytics are ML now, driven by the vision models are on ML. So analytics completely is taken over by ML. I think there is no application which is not touched by ML now. So in that sense, even 50% is, I think, underballed significantly here. Maybe it's to the tune of about 70, 80% at the edge. So on the customer interact, I think we talked about it. I talked about it. My fellow panelists talked about it. The different IT environment and setup. So how do you bring this all together? As I said, CIOs are already having multitude of these use cases deployed. The systems, how do you ensure that one can get saved from technology obsolescence, and future investments are protected, or the current investments are protected in the future. Security we talked about, and skills. Rishi brought skills, I think, at the start of his commentary, and he talked about skills. Now, it's the skills are two-way kind of skills, and one of the design principles, once again, when I talk about Cloud Light, and it's part of the solution, is that we are providing a very strong managed services framework around what we provide. That means we completely handhold, we do managed services. But one more very important thing which I'll talk about when I'm presenting the stack view is that we've made sure that every layer, the technology which has been is not proprietary. So in that sense, these come from the open source world. Our stack is, I didn't talk about it, but our stack is built on upstream Kubernetes. It's and Kubernetes skills are available. Every engineering college, whether it's in tier 1, tier 2, tier 3 is teaching Kubernetes now. So I think those skill sets are available in plenty. All the platform services we talk about, I'll talk about it. I think I'm getting ahead of myself here, is all because I'm excited that we're building something which our new engineers, newly minted engineers can grapple with easily. So in that sense, it's not a very difficult skill set, but skills, once again, the reason why bringing skills is sometimes in a enterprise context, when you lose such kind of folks, it's, it takes time to fill them up, and then if your critical applications on the shop floor, let's say, are running on these systems, and you lose a critical skill set, you don't want to be like left. Though we are claiming that these skill sets are available in plenty, but still there could be some gap, and we don't want to have that gap. Therefore, we are providing a complete managed services layer. I talked about software defined. The systems are completely software defined, so you can keep adding hardware because it's software defined, right? You can add more storage, you can add more hardware, you can add more, networking gear because that's also we can make it software defined. So all that can be done. And a standardized way to deploy, because you have a single Kubernetes environment, you can, manage these thousands of virtual machines, thousands of containers from a single pane of glass. So that's what our solution is all about. Without much ado, let me just talk about CloudLight here. So it's I think one of the questions you asked was how we define CloudLight, which is infra and cloud agnostic to begin with. I talk about multi-access edge, the ability to run 5G as an access layer, the ability to connect to a software-defined WAN environment through SD-WAN. We work with many vendors. We've done FortiGate, we've done Versa. We can add more, Cisco, etc. I think that should not be an issue because finally the platform is built on open source technology. So we never get worried on, whether this use case will run or not, whether this workload will run, as long as their containers or virtual machines, as long as they subscribe to some open source standards, I think that's not an issue. And I talked about expertly managed platforms. So enterprises require that kind of support, that kind of SLA. So we provide it through our day 1 and day 2 service through our managed services and professional services arm within Tata.com. So this is what I talked about. This is the stack view of how I described in words, in English words. So if you see at the bottom, we talk about the security. So from a security point of view, we provide container runtime securities, which once again comes from the Kubernetes world. And so you'll be able to run in a multi-tenanted way. If you have multiple plants, you can actually create environments which are isolated and still are very secure through container runtime. Zero trust all the way, because you have a single pane of glass centrally. So we have a zero trust connectivity between these thousands of edge deployments. And so because of the zero trust, we make sure that we not only protect data at rest, but we also protect data in motion. Therefore, where our customers should not be worried that somebody could hack and do something to the edge computing devices and platform at the edge, right, and infra at the edge. And we provide a complete DevSecOps cycle. So that's provided out of the box. When I talk about agile and agnostic, there are 3 flavors to CloudLight. Very important. I never talked about it because when we talk about edge compute, and the flavor which we got from our panel discussion is that it's on-prem, because we talk about ultra low latency use cases. React in real time. Satya talked about it, that you should not have vehicle accidents. So that is like on-prem. So the on-prem is the one edge in a box solution which is on-prem. But there is a near-prem also. So we have edge POPs available. So not all use cases. So the use cases also can be categorized as per the latency characteristic. And if you don't have a data residency and sovereignty challenge, that means you're okay with data going out. For example, retail environments. Very small retail stores might not have enough space and power to put an edge box. So they might want to have, but they still want to run some edge use cases like a digital signage use case. You can run it on-prem, you can run it at a 30-40 millisecond maybe latency. I'm not sure, but maybe you can. So there are some category of use cases which can live with 30-40 millisecond. For example, video streaming, you don't need on-prem, right? even a high definition video streaming, maybe not 4K, but high definition video streaming with a good bandwidth can be done from 30, 40 millisecond location. So we have what we call as edge pops located, and these are running the same platform, extensible platform, and you can, it is available as a SaaS platform. So software as a service, you just subscribe to it like a cloud. It's like a cloud, but a mini cloud at an edge pop, which is a 30, 40 millisecond round trip time away, as opposed to an availability zone from an hyperscaler, which could be 200 to 300 millisecond round trip time away. So as I said, the use cases are different there. The on-prem is SaaS based. And the last but not the least, craft your own edge. That's for very large enterprises who want to build their own edge. So they have their own hardware and infrastructure, and we provide the software, and you can craft it your own way. We only provide you the software as a license, not a perpetual license, once again as a service. So in an OpEx mode, but enterprises can then build their own edge depending on how many use cases want to deploy. This is for very large enterprises who want to control what they're building at the edge. They don't want like a SaaS-based platform where they will depend on us to provide the underlying hardware. Here, let's say, think about large enterprise like Tata Steel, right? So they would want to build their own edge. So we provide just purely the software stack, right? And then every layer, every piece of infra is software defined. I've talked about it a lot, so I'll skip that layer. A very important layer from an edge computing point of view helps you control the edge computing platform in a very granular fashion. And then the orchestration, provisioning, and managing. So completely through a single pane of glass, you can do that. But that part, we have introduced what we call as AI ops. So very interesting. So we were, as part of our embedding AI, and specifically Gen AI in all our products, this Gen AI embedded into our Cloud Light. This is part of our, this is going to be part of our latest release. We have not done the release yet. So let's say this is not G8 yet, but this is going to be G8. So what we did was, for when you're deploying thousands of edge locations and you have an administrator, you don't need to every time open a GUI and define, put the IPs, define the virtual machine, what's the size of how many vCPUs you want to allocate, what's the RAM you want to allocate, what are the NIC ports and everything, right? So what you essentially do is like we do with ChatGPT, right? So what we have done is we've created this whole LLM, and we trained an LLM to take this input in the form of simple English words, right? So you can, an IT admin can type, create, 50 containers in these locations, right? X, Y, Z location with this RAM, with this, and within 2 minutes, it'll come back and say created, right? So what it does is, we have API integration with this edge computing. So it translates through a large language model, is able to understand this, convert this into a requirement. Through APIs, we are able to deploy this. So this is from an AI operations, from a deployment, we will extend it to, so this is for provisioning right now, and a little bit of orchestration from a management point of view, ticketing, etc. We are introducing AI ops. So I think Gen AI I'm talking about. So that we will do. So that's AI driven. Data I talked about. I specifically didn't talk about PaaS capabilities in a big way, but we have most of the PaaS, which typically the developer world use these days from a database point of view, whether it's Redis or Postgre for structured, unstructured data, MongoDB, or semi-structured, and most of the open source world data warehouse, whether you're talking about Hadoop or etc. So all that will be available, or anything which is built on Apache Spark will be available as a PaaS service. Very importantly at the edge, because there is a lot of data which is exchanged between IoT, so you use a lot of MQTT and streaming, so we have Kafka as a service, we have MQTT as a service, so those are all part of PaaS capabilities. When I talk about as a service, what I'm talking about is these open source technologies are in a managed services fashion offered to you. That means you don't have to work, you don't have to depend on the open source community if you have a challenge, right? So when you build these use cases, building these tools, these open source technologies, we support it, the underlying technologies we support it through our managed services platform with SLAs. Then on top of it, I already covered it, LoRaWAN, private 5G, SD-WAN. The access technology is available out of the box. And then we have specifically on certain verticals we have worked on and created some use cases, created some drivers. I don't know where Satya is, so we have done something on, hi Satya, we've done something on software-defined vehicle and V2X space. It will be good to talk about it because we have, as you know, as part of the group, some companies which are in the automotive space. And then IoT, of course, we have IoT drivers out of the box. Move is another product from Tata.com. Basically, it's an eSIM, embedded SIM. It can be eSIM or a cloud SIM. And typically, we put it in vehicles. We are putting it in now, for example, machines. Anything which is mobile in a supply chain, it makes a lot of sense. So to track in supply chain, inside the warehouse, outside, both on inbound and outbound supply chains, Move makes a lot of sense. So what we have done specifically from a use case point of view, because it will become very theoretical otherwise, what we have done is, when we have it within the automotive vehicle, there are plenty of use cases which happens inside an automotive car, apart from collecting all the data from telemetry, etc., and helping understand, diagnosing, etc. There is also in-vehicle entertainment. So what we've done is, along with Move, we put our Edge Pop there, Edge Computing Cloud Light Pop, and use our CDN service to stream videos, high definition videos, and maybe even 4K videos if it is possible, if the network supports, into the cars, right? For rear seat passengers, video screen for luxury cars, of course, that's available. That's one of the use cases. So we are able to do a streaming without any challenge, without any buffering, etc. Then media and vision, we talked about a lot of vision use cases we have collected, along with our IoT teams, which also have vision use cases, and also third, as I said, ISV. A robust partner ecosystem, I talked about the marketplace very importantly, and some of the initial verticals where these use cases are available have been listed here: retail, manufacturing, BFSI. We started working, ATM in a box, etc. as a use case. Healthcare, we just started working. Smart cities and energy utilities coming up, so we've started looking at what use cases make sense. And I have 3 use cases as examples where customer use cases which will make sense, so I'll skip to those use cases. So this is a QSR chain, which is in the business of selling pizzas, very large chain. And so this is not a very traditional low latency use case, but it's another challenge which is solved by edge computing. So a typical outlet of this chain has a POS machine, which we all know. It has a kitchen management system. It has an inventory management system, an order management system, because orders comes, you have walk-in customers who are placing orders through the POS, and you also have orders which come through Swiggy and Zomato, and their own app which comes through their cloud, right? So, and then you have SD-WAN in the store, and then the supervisor or the manager system, right? So these are various application footprints. So for each of these application footprints, they used to have a PC there, a flat screen there, SD-WAN CP, which is a device, a black box, a device, etc. So you have plethora of devices, and then you have Wi-Fi also running, and then you have a couple of video analytics use cases with its own DVR, right, digital video recorder. Just imagine a small 700 square feet store. We don't tend to see it, but if you see, there are 2 cameras, there is something hanging out there, there are a lot of wires there, some screen in the kitchen on the wall, some PCs lying underneath the supervisor's table. We don't care because we are there to have pizza or whatever, or burger or whatever. But what happens is it's an operational nightmare for them, right? At some point or the other, some POS machine will be down, some broadband SD-WAN device will be down, or a manager's PC is down, so therefore they're not able to log in. The employees are coming in when they're logging out, because that all happens. Or at worst, if the order management or kitchen inventory management is down, order management, then you can't take orders from Swiggy and Zomato. So these guys, sometimes your Swiggy, Zomato, when they get delayed, when they're waiting for their orders, actually it is their system is down. So they don't know the order has come in, they're waiting, right? So till the machines are up. So what we did was we consolidated all of them into a single platform. And when I say platform, it's not a big, rack optimized server as we see it, but a small box which can come in the top of my hand and can withstand temperatures from, minus 10 degrees Celsius to 55 degrees Celsius or whatever the operating range, a ruggedized box. We consolidate all what I said into a single such box. And we provide another box in an HA environment. Voila, you have a 99.9% uptime for the store. And operationally, you have just two boxes running all these in a virtualized fashion inside the edge computing device. And then you're able to, and you have thousands of stores, you're able to control all of that. You're able to see what challenges are happening, where CPU utilization is going up, and where your RAM utilization could be going up, or network is getting choked, or whatever, or SD-WAN device is not, or the SD-WAN VNF is not functioning properly. All that can be done from a single pane of glass, and you can generate reports and reporting and all that, right? So what it meant, which is what Satya we talked about, the outcomes, right? So that was a challenge, but it has to still have some outcome, and the outcome is qualitatively reduction, 50% reduction in footprint. Though we can quantify it, but customer says, hey, you know what? I'm already paying rent for it, so don't quantify it. It doesn't make sense from a justification point of view. But 23% operational efficiency directly relating to reduced managed services costs. So this is quantified. Next is 70% increase uptime in IT infrastructure. This is where what used to be hitting under the belt in terms of, it's a double whammy, right? So your customers are walking in, systems are down, you're not able to process their orders. Swiggy, Zomato orders are coming in. So even a 10-minute downtime on a weekend, on a Friday or a Saturday evening, when most of the pizza eaters are out there in the store, or Swiggy, Zomato guys are lining up to pick up the orders for their customers, you have a downtime going to go bonkers, right? And even if you have thousands of stores, 5 stores are having downtime like that, huge impact on, we've been told about 25 crores is what they lose, and 70% increase means directly improves, helps them conserve that revenue which they would have lost otherwise, or at worst, not only lost, but a disgruntled customer walking out saying that they couldn't have their pizzas, right? And then last, up to 40% cost savings in the infrastructure itself. Here it is operational efficiency from a managed services point of view. There it's infra, which because you are consolidating all the infra, you're able to reduce the infra cost. Fantastic use case. It's not low latency use case, but a classic edge computing use case. We're able to consolidate all infra on a single platform and manage it beautifully from a central location. So the next one is from one of the group companies. We'll be working on IT-OT integration, where we're picking up all the data from their OT systems, mainly PLC systems, and human machine HMI. And we are integrating with some of the enterprise data systems like SAP and ServiceNow. And we're bringing all the data to the same singular data platform through this integration. We're working with one of our ISV partners here, and we are able to create a single view of what's happening to the data. And now we are applying more ML algorithms. So this is work in motion right now. And the initial use cases which we have deployed is on predictive maintenance and improving understanding of what's happening to the machines, whether it's a conveyor belt or it's an assembly line. Now we are applying it to energy management systems. We're also, which is basically the paint shop, because paint shop consumes most of the energy in an automotive manufacturing unit. And then we're also applying it to other parts, including the warehouse, etc. So this is a fantastic use case of IT-OT integration. I'm not saying that we've achieved the holy grail here, but I think we're moving in the right direction, and the initial outcomes are justifying what we are trying to do here. That is on IT-OT. The next one, the last one, before I wrap up, is once again a large fashion retailer into jewelry, eyewear, and watches. I think it's easy to guess which fashion accessory retailer it is. So these guys, this is an innovation project, okay? So this is not like a problem statement, and then, so this is basically pushing the envelope of edge computing and saying that, okay, how can it help me innovate and bring in some new wow experiences to the customers, and maybe in the process also help me, improve the conversion rates, and therefore, have an uptick on the revenue. So the use case setup is like this, and we are productionizing it as we speak. In a typical store, this is a large format store. This is not a QSR, small 700 square feet, right? This is a large format store. So you have high value, because we're talking about luxury items here, so this is a high value store. So what we do is basically, earlier they had these dumb screens at various places. When I say dumb, these are simple LED screens running static messages from morning till evening, right? The store manager comes and puts some USB and updates the messages, and something runs. Now what we did was that we put a camera on top of it and connected that camera on a 5G device, 5G dongle to our edge computing platform, in which our 5G core and drivers are running. And very importantly, what we've also done is put a vision model to understand who is in front of the camera. So when I'm talking about who, we are making sure that it is not identifying who you are in terms of your name and etc. Right? That is not something which we are bothered with, and that's something which we will not do. So no privacy violation here. It's just to find out who you are in terms of your demographics. You're a male or a female. What could be your possible age, range, etc. And also the store cameras, which are, so this is a camera, mind you, on top of the digital signage or the TV, right? And there are other store cameras also, which are also looking at how the shoppers are behaving. So we also record which, if you have already gone through some aisles and looked at certain, displays, then we correlate that with the age, with the, the sex, and then we are able to, in real time, in a very highly contextual manner, throw out the right kind of offer to you, or promotion to you, or show you some ad instead of having a static. So every time somebody passes in front of the TV, something new will come, depending on who the person is, or give an instant discount to something which you have spent time on, right? Requires a lot of ML, because you have to do all these vision models run on real time. You're running on 5G because you want to be able to do it, because if you're not able to do it in, about this, they had given us about 1 second, but we are doing it within 500 milliseconds. Otherwise, you will pass through the screen and you will not realize, right? So this has to be real time. So this is what we have done. We are seeing initial very good customer engagement, not able to see quantified. I talked about less than 1 second round trip time. So you're able to, the person is in front of the camera and within 1 second something is done, but we measured it within 500 milliseconds, which is half of 1 second. And then conversion rates of up to 30%. So that's the, I think, final one which I wanted to show. And if there are any questions, thanks a lot. I wanted to make it quick. If there are any questions, happy to take it. Please let me know. Thank you.
Yeah. Thank you, Neil, for that extremely insightful and a brilliant presentation. With this, we come to the end of this conference. Thank you all for joining us today. It's been personally a very interesting learning experience for me as well. Trying and understanding various nuances and perspectives around edge computing. And thank you all for joining us today. And I do hope that you stay on for dinner and all, and you interact. And the representatives are here. Even if you had questions but you were unable to ask, this is your time to shoot. Thank you all. Thank you.